This is Mr. Anderson for Kellogg Community College. Today we're going to be doing Chapter 2, Section 3 of Trigonometry. We're going to use the fact that trigonometric functions are periodic to find the exact value of each expression. Do not use a calculator. What you'll need is you'll need your unit circle. So here's the unit circle, and here's your worksheet. Go back and forth between the two of those, and whoops, let me clear out some of these menus here. All right. Okay, good. So what we will do now is we will look at all the functions are periodic within 360 degrees. It is important to see that there are two functions, the tangent and the cotangent, which are periodic within 180 degrees, which means that they will overlap or they're equivalent to smaller values of themselves within those circle rotations. So for example, the first problem here, which is the cosine of 420, is periodic every circle, or every 360 degrees. So we're going to subtract 360 degrees from the 420, and what we're left with is the cosine of 60 degrees. And from the unit circle, the cosine of 60 degrees, which is our x value at the 60 degree mark, is 1/2. And you can see that by looking at the unit circle here. Excuse me. At 60 degrees, the x value is 1/2 right there. All right, so let's move on to the next problem here. Whoops, there we go. The sine of 390 degrees, again, periodic within 360 degrees. So if I just subtract 360 from it, I can go get that total there, which is going to be our 30-degree angle. So this is equivalent to the sine of 30 degrees. And if we look at sine of 30 degrees, which is the y value at 30 degrees, this is going to be equal as well to 1/2, like this. And I will show you that when I switch back to that screen. But before I do, let's go to the secant of 540 degrees. So each of these you would subtract 360 from them. And this would be equivalent to the secant of 180 degrees. Now without flipping back to the unit circle, at the 180 degree mark right there, the point is going to be -1, 0. Secant is the same thing as 1 over cosine. Cosine is the x value there, so 1 over our cosine, which is -1, is the same thing as -1. The secant of 420 degrees, if I subtract that, is the same as the secant of 60 degrees. Since this is one revolution around the circle and then back to 60 degrees, secant at 60 degrees is going to be the 1 over the cosine at that 60 degree mark there. And at that 60 degree mark, the answer for the x value is 1/2, and since the x value is 1/2, if I flipped 1 over 1/2, or 1 divided by 0.5, the answer would be 2. So the secant of 60 degrees is 2. And we can see that on our unit circle. So reviewing the problems that we just covered here, the sine of 30 degrees, this is problem 2, is the y value. And that y value is right there at 1/2. The secant of 180 degrees over here is going to be 1 over this -1 right there. And then the secant of 60 degrees, at that 60 degree angle, it is the 1 over the 1/2 value, so the 1 over 1/2 is 2. Alright, so now we're going to take a look at the, let's see, there we go. Now we're going to take a look at these functions down here, which is the radian functions, and these are also periodic on the unit circle. 9/4, and what I'll do here is to kind of show you equivalent periods around the circle. 9 pi over 4 is the same thing as 8 pi over 4 plus pi over 4. What this means is that this gives me 2 pi plus pi over 4, which is 1 revolution or 360 degrees. So this is sine of 9 pi over 4 is the same thing as sine of pi over 4. And sine of pi over 4 is the 45 degree mark, which is the y value at 45 degrees is square root of 2 over 2, using your unit circle. And again, since this is, now with this problem here, this is 9 pi over 2, what I'm going to do is separate this into 4 pi over 2. And the reason why I'm going to use 4 pi over 2 is this simplifies to 2 pi, which is 1 revolution. So this is 4 pi over 2 plus 4 pi over 2 plus pi over 2. So 9 pi over 2 is going 2 revolutions around the circle and ending at pi over 2, which is 90 degrees. So the cosecant of pi over 2, or the cosecant of 90 degrees, is going to be 1 over our sine value, and the sine is the y value. So at that unit circle, we'd be at 90 degrees, which is 0, 1. So 1 over 1 is the same thing as 1. Okay, the cotangent. Two ways to look at this, because we know that the tangent and cotangent are periodic within 180 degree rotations of our circle. We can see these as 17 pi is going to be equivalent to the cotangent, not cosine, cotangent of just pi. Because our cotangent and tangent are periodic within every 180 degrees, not every 2 pi, but every pi. So this means cotangent of 17 pi over 4 is the same thing as the cotangent of pi over 4. And so that gives us a very nice shortcut to this problem, because the cotangent of pi over 4 is going to be looking at that 45 degree mark where it's x over y. And the x value is square root of 2 over 2, and the y value is square root of 2 over 2, and anything divided by itself is 1. The secant of 25 pi over 6, what we should do is take this fraction and make it periodic around the unit circle, which means we're going to try to look at ways that this can be 2 pi, and the double of 6 is 12, so this is 12 pi over 6, plus 12 pi over 6. That's 24 pi over 6 plus another pi over 6. This gives me the equivalent, since all this adds up to 25, the secant of pi over 6. Now, the secant is the same thing as 1 over cosine. And our x value at that point, at that mark, is going to be 1 over square root of 3 over 2. So what this is going to make it's going to make a 2 over square roots of 3. And that 2 over square roots of 3 is going to then need to get our denominator rationalized. So here we have multiplying top and bottom by square root of 3. So what we have is 2 square root of 3 over 3. Now what I'd like to do is I'd like to go and show all of those problems, 5 through 8, back on the unit circle here. So let's go and take a look at the unit circle. And the unit circle here has, let's start off with problem number 5, which was the sine of 9 pi over 4. This gives me sine of sine of pi over 4. So that's our y value, puts us right here. There's our sine of pi over 4, which is square root of 2 over 2. The cosine of 9 pi over 2 is the same thing as the cosecant of 9 pi over 2 is the same thing as the cosecant of pi over 2, which is 1 over our y value, so 1 over 1 is 1. The cotangent of 17 pi over 4 is the same thing as pi over 4, and the cotangent is, x divided by y, and anything divided by itself is 1. Finally, with the secant of 25 pi over 6, that is equivalent to the secant of pi over 6. So here we are at pi over 6 at this 30 degree mark here. The x value is square root of 3 over 2. So if I flip that on its head, because it's the secant is the reciprocal of 1 over cosine, this gives us 2 over square roots of 3. We can rationalize the denominator to make 2 square root of 3 over 3. Now what's going to end the first part of this video is going to be a little part talking about naming quadrants where the angle lies. It's going to start off pretty straightforward, but I'm going to get tricky by the end of this section here. So the first part is going to be the sine is less than 0. Now remember, sine is normally our y value, and since the y value is less than 0, we're going to have a negative y. So in our ordered pair, our y is going to be negative. The cosine will be greater than 0, and since the cosine is normally our x value, so our x value is going to be positive. So this positive x value and a negative y value on the unit circle is going to give us into which quadrant. It might be helpful to have a unit circle here and have the both x and y positive here. In the third quadrant, x and y are both negative. Fourth quadrant, x is positive, y is negative. And this is where our angle is. If our angle has a negative sine and a positive cosine, we're in the fourth quadrant. If it was the other way around, it would be in the second quadrant. Now here, our cosine, our x value is positive, so I have positive x, and our tangent is also positive. The definition of tangent is y over x. Now if x is positive, then y would also have to be positive for the tangent to be greater than 0, or positive. So with x and y both being positive, this is going to be plus plus, so this is going to be in the first quadrant. Again, the reason why I could deduce that is since the tangent was greater than 0, I had to deduce that the y was also positive with the x. Cosine is less than 0. So the cosine is negative, so that means my x value is negative, so I'm either in the second or third quadrant. The tangent of theta is greater than 0. So for me to have y over negative x to be positive, I would have to have a negative y as well. Well, with both my negative and x and y negative, that would put me in the third quadrant. Finally, the cosecant, which is 1 over our sine value, which is y, is going to be greater than 0, so my y has to be positive. And my cosine is less than 0, so this is my negative x. So with a negative x and a positive y, we now go to the last quadrant we haven't talked about yet, which is quadrant 2. This ends the first part of our multi-part video on this chapter. Thank you for watching.